So class 12, I thought I could record this for you because you couldn't make it to class today. And it really follows from the lesson we had on Friday, I think, on the sum to infinity. So how do we apply that to some other types of questions? So for example, if they give you this, rational recurring number like 4.81, where the 8 and the 1s are the ones recurring, and they want you to find this, or they want you to represent this as a fraction, as something divided by something, right? So how do we go about doing this using our sum to infinity formula? First of all, let's notice the pattern that's happening here. So if our first term is 4, we are adding this 4 with the 0.81, and we're adding this to another 0.0081. We're adding this to another 0.000081. So basically this is the pattern that is happening there. And what I'm doing is I'm just rewriting these recurring decimals over and over again, adding more and more zeros. So if we don't look at the 4, maybe let's just not look at the 4 right now. We'll add the 4 at the end. Let's take the 4 out. So technically, if we take the 4 out, then this will be our first term, right? So our A in this case will be 0.81, and our R that is happening from term to term will be that we are timesing by 1 over 100. Why? Because you keep moving the decimal, the zero, the comma there, 2 units to the left. So that is just like dividing by 100 or timesing by 1 over 100. So that is the R that is happening here. So we have the A, we have the R. We can actually find what these numbers, if I keep adding them up to infinity, what are they equal to? And that term is called the sum to infinity. Sorry, my infinity symbol looks weird. We have the 0.81 at the top. We have a 1 minus a 1 over 100 here. And if you plug this into your calculator, you end up getting the fraction 9 over 11. So that guy, if you add the 4 that we initially had up here, then you will end up getting this simplified fraction, which is 53 over 11, or if you want to write it as a mixed number, it's 4, 9 over 11. So that guy actually can be represented as a fraction as this, or that guy. Hope this makes sense. So again, what did I do? I first wrote it out as a pattern, right? And then I found what the A value was. I then found what the R value is, the constant ratio they keep dividing or multiplying with. Then I used my sum to infinity formula, substituted, got this answer, but came back to add the 4 that was represented by this whole number there. And when I add the 4, I get this final improper fraction, 53 over 11, or 4, 9 over 11 is a mixed number. So that's how you would solve that. All right, now let's look at how you would find the value of R. So let's say they give us something like this, P plus p1 plus p, and this is adding with another p, but this time it's squared, and it obviously keeps adding all the way to infinity. So if they said this is a convergent series, if they already told us that it's a convergent series and they wanted us to find what the value of r is, one thing we need to remember is that if it's a convergent series, that means r lies between 1 and -1. It will always lie between that range. So how do I represent this? R, remember, is always t2 divided by t1. So I'm going to take term 2, which is this guy. I'm going to divide him with term 1, and I'm going to put him in this inequality there. So I have my -1 there, and here I have my term 2, which is p1 plus p, and at the bottom I have my p there. And if you divide these, the p's are the ones that cancel. You end up having -1, 1 plus p. Then if you take this 1 over and it goes over that side, you end up getting a -1 minus 1. And here you end up getting a 1 minus a 1. So actually our p value is going to be between -2 and a +0. So actually the p value in that formula there that we had at the top will have to be in between this range to actually make it a convergent series. And then they say calculate the sum to infinity of this. Then you'd say sum to infinity is equal to a over 1 minus r. Remember what our a is. A is the first term, which was the p. The r is the second term, which in this case, our r is there timesing by 1 plus p. Where am I getting this r? You will see that from there to there, they're timesing with this bracket here. From there to there, they're timesing with the same bracket, and that's why we have the squared there. And so that is our r. If I were to substitute in this equation here, I'd get a p at the top, 1 minus bracket 1 plus p. And if I were to solve this, I have a p at the bottom, I have a 1 minus p. -1 and the -1 are going to subtract, then I will get this. And if you divide this fraction, the sum to infinity is actually a -1. So these were the concepts that I was going to go through with you during the lesson. These speak more on Friday's work, the sum to infinity. But in the second lesson, another thing that we were going to unpack in the second lesson during the double is this whole idea of sigma notation. So what does sigma notation actually mean? Sigma notation is just a way that we represent our sums, our series. So the symbol here that we see in front of you guys, this symbol here stands for sum. It's a Greek symbol that stands for sum, or S. So that's how you write it. And usually in front of the sum, this is where we're going to have our Tn. Our Tn formula. Remember, if it's an arithmetic, your Tn follows the general formula where A plus open bracket n minus 1 times a d. If it's geometric, it follows A times the r to the power of n minus 1. So that's the Tn that usually fits in here. So let's take an example where our Tn is 5k minus 3. Then what goes down here? What goes down here is the starting point. And then what goes up here is the point at which we're going to end. This is our last point. So let me just label these components. So this is our starting point. And this is our ending point. Or rather, your last value if you want. And we can actually calculate how many terms there are using the end value and the starting point. It's always n, the number of terms is equal to the top minus the bottom plus a 1. You always use this formula right there. So we're given this and we're asked to evaluate this. So what does that mean? It means first of all, step number 1, you need to find the terms of the pattern. So what do I mean by that? In this formula here, you're going to substitute for k. You're going to start with this value here, the 1. And you're going to substitute for k and you're going to keep finding each of the terms. So the first term is going to look like this, which is a 5 minus a 3, which is a 2. The second term is going to be a 10 minus a 3, which is a 7. The next term, the third term, is a 15 minus a 3, which is a 12. So actually my pattern is a 2 plus a 5 plus a 7, and this keeps going. So what is happening here? We see that our D is actually, sorry, I put the wrong values there. There was a 2 plus a 7 plus a 12. So our D that is happening there is I'm adding a consistent 5 there. So our D is equal to 5, our A is equal to 2, and our N, we're going to just take the top, which is a 7, minus the bottom, which is a 1, and I'll add a 1. So our N in this case is actually equal to 7. So I have all of this, and I'm trying to find what? Remember, what is the whole point of this? We're trying to find the sum, but this is an arithmetic pattern, so I'm going to use the arithmetic sum. And it looks like this. I'm going to use this one, not the one that uses the L. And if you substitute, N is 7, A is 2, and your D is, what is it? It's a 5. And you plug this into your calculator, you will get what the sum to infinity is. Not to infinity, rather, the sum to 7 terms. Let me check. It's 119. And there we go. The sum to 7 terms is 119. So that's how you work with sigma notation. Let me take another example. Let's take that it's sigma notation, the sum of 3 times 2 to the r, where your last point is a 9 and your r, your starting value, is a 0. So again, step number 1 is to find the pattern. So 3 times 2 to the power of 0. You always start with this first term that is given there. We're going to get a 3. 2 to the power of 1, we get a 6. 3 times 2 to the power of 2 is a 4 times that is a 12. So my pattern is actually a 3, that is adding a 6, that is adding a 12. So clearly this is an geometric where they're multiplying a 2 in each of these cases. So A is 3, our R is 2, our N equals to the 9, the top, plus the bottom, minus 1. Wait, what is the formula again? It's the top minus the bottom, plus a 1. So this is incorrect. It should look like 9 minus 0 plus 1, which will actually give me a 10. So there's my N, there's my A, there's my R. I need to use my sum the sum for a geometric. Looks like that. Remember, we use this one if R is greater than 1. Then we just substitute 3 open bracket 2 to the power of 10 minus 1, all divided by 2 minus 1. You plug this into your calculator, you get 3069. And there we go. So this is how you work with sigma notation. Again, let's just revise what you need to do first. You need to first find the pattern. And once you've found what the pattern is, you can find your A value, you can find your R value or D value in a arithmetic pattern, it's the D value. Then you can find your N as well. And once you've found those, you find your Sn, you substitute in your sum formula, and you just find what the answer is. And that's how you work with these type of questions. But sometimes they want you to take a pattern and actually write it in sigma notation. So how does that work? Let's take the pattern 2 or the series 258, and this is being added up all the way to 83. So the first thing we need to establish is what is our A. Our A is quite easy, it's a 2. Our D in this case is quite easy, they're adding a 3. Then what I need to find is I need to find what N is. But how do I find N? I need to substitute this guy. So find my Tn formula. It's an arithmetic pattern obviously, so I use this Tn formula. Then this will be my 2. Then this is how it looks. It's a 2 plus 3n minus 3, which is a 3n minus 1. So that's my Tn formula. So what does that tell me? It tells me that in my sigma, in brackets here, I will have this formula there. But where does it start? It obviously will start at n is equal to 1, because if you substitute 1 in this formula, you'll get the 2. So it starts there. Where does it stop? We need to find what n is to see where it stops. So how do I solve for what n is? I will substitute 83 for Tn. The last term, where am I finding my 83? The 83 actually comes from this guy. So if that's my last term, I substitute 83 in there and I solve. 83 plus 1 all divided by 3 will give me what n is, and n is actually equal to 28. Yep. So if that's 28, it tells me that now the last value would actually be 28. That's the last value that I'm going to substitute. So this is my sigma expression, my sum sigma expression. All right, so that's it from my side. This is all that I was going to go through with you in class. Give me a second, I'll be done just now.
No, I just want to know, are you in here after break, or did we
No,
swap
no,
rooms?
no, you guys are in here. Yeah. All right. So good luck, guys, and yeah, I hope you guys understand exactly what's happening here. If you have any questions, you are allowed to ask me. Thank you. Bye.